so where we are going to begin today is just reviewing the journey that we went on the last class, because we covered a lot of territory. So before we move forward, I want to check and see what we remember and what we remember correctly. So who can tell me just one thing that we learned in the prior class? Yes, Sophia?
The 6 trigonometric ratios.
We did. We did learn the 6 trigonometric ratios, and give me an example of one.
Sine, which is opposite of hypotenuse.
And sine of what?
Sine of theta.
Yes, sine of theta is opposite over hypotenuse. Okay, even with just that one, I'm going to have to adjust to where my boundary is here. That's losing a lot of space. I'm going to go ahead and put it here. Just, I'm going to rotate the camera. Bless you. Okay. So, but even just with this, we've introduced theta, opposite, and hypotenuse. So these were 3 other things that we went over. So before we move on to some of the other things that we learned, who can explain what one of those 3 items is? Yes, Zena.
So theta is the angle that you're trying to find.
Yes, or theta is the angle that we have. So sometimes we're looking for it, sometimes we have it. But theta becomes our new sort of entryway into the triangle. Very good. Okay, so there's one of the 3. How about opposite? Yes, Miles?
The opposite angle is the angle opposite from the hypotenuse. I think.
Well, is opposite an angle or side? Because we are definitely talking about opposite, which means it's something across from something else. But in this case, the O opposite is across from what? Should I phone a friend, Miles?
Yes.
All right, Cade.
Opposites across from theta.
Yeah, so opposite is the side. Put this one in green. So opposite is the side that is across from theta. So theta is the angle, opposite is the side that's across from it. The hypotenuse is always what, even if we're not worried about theta? There we go, it's the longest side. Okay, so now we get to a slightly more broad question. We'd introduce theta because we're sort of introducing the ascendancy of considering the angles of a triangle as opposed to its side. But why is that? Why is that necessary? Why not just sort of stick to the sides? What is it about the angle that makes it more important than the absolute lengths of the sides? Yes, Quinn?
If we know the angles, we know the proportions.
That's right. So if we know the angles, we know the proportions, and that is independent of the size of the triangle. It could be a big triangle, it could be a little triangle, but if we know the angles, we know the proportions. And in fact, we can see that right here. The formula for sine is a proportion. It's the ratio of the length of the opposite to the length of the hypotenuse. And that's independent of sort of the magnitude of the triangle. Very good. Okay, who wants to give me another one of the 6 trigonometric functions? Yes, Alex.
Secant.
Yes, secant, and what is secant?
That is hypotenuse over opposite.
Those over adjacent.
Is it?
It's over adjacent.
Oh,
yes.
adjacent. My bad.
The secant's the one that's got the good sense of humor. Ha ha ha. Oh, Miss Ferris. I can't stop. There is no off position. Okay, good. So we've got 2 where there are 6 of them. Who can give me another? Yes, Taylor.
Cosecant, hypotenuse over opposite.
So cosecant is hypotenuse over opposite. Just cannot get enough of the winter holidays. Okay, we've got 3. We've got half of them. Yes, Zena, and then Cade.
Cosine, which is adjacent
Cosine knows how to relax. Yes, Cade, what's another one?
Tangent,
Yeah.
which is opposite over adjacent.
Very good. And so finally, our sixth buddy.
Cotangent.
Yeah, it's cotangent. This one likes to take a nap. So sometimes these, like the little sort of like acronym, although I think there was a teacher that kind of got canceled for sort of turning this into something inappropriate. SOHCAHTOA, I don't know, they were kind of turning it into like some sort of like,
I heard about that.
like it was sort of like mocking Native American tribes or something like that, like so useless, so needless. But anyway, SOHCAHTOA, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over. So SOHCAHTOA is kind of an easy thing to remember that helps us to remember sine. Cosine and tangent, far less known, definitely the B side of this album is CHOSHAKOW, which nobody says unless you've had trigonometry with me, because I like to say CHOSHAKOW. So we've got SOHCAHTOA and CHOSHAKOW, and these are our 6 trigonometric functions. Although as I'm seeing, we heard the word adjacent over and over again. Well, there's only one side left on the triangle. And what's the definition of adjacent?
Next to.
Next to. And so this is the side that's next to theta. Okay, so now let's go ahead and one of the triangles that you all found that was a formerly known as Sumerian triple, or no, Pythagorean triple, now known as a Sumerian triple. So here we have a right triangle that has all whole number sides. So this is one of the ones that we kind of found together in class last week. So now this is how we apply it. If I say, what's sine of theta, you tell me. A little louder?
5/13.
Yeah. How about, now sometimes it's easy to get disorganized. So oftentimes when I'm doing these problems, I will do a quick sketch of the triangle on my paper, and if this is theta, then I will actually label these O, A, and H, so I'm sure that I'm keeping them nice and tidy and organized. Because it's easy to start getting them backwards. Okay, so let's see. Yes, Ollie.
It's 12 over 13.
It's 12 over 13. Because cosine is adjacent over hypotenuse, and our adjacent is 12, and our hypotenuse is 13. All right. I'm throwing this one to you, Jasper. If tangent is opposite over adjacent, what is our tangent going to be on this triangle?
Can you say that again?
Yes. So as a reminder, we've got it written here, but sometimes I'll rewrite it because, again, it's easy to get disorganized. So tangent is opposite over adjacent. That's exactly right. So this is going to be 5 over 12. Okay, the reason that I suggest always organizing your 6 trigonometric functions in this order and kind of being a good and sort of like slightly compulsively organized about it is because once you have sine, cosine, and tangent, what's the only thing we have to do now to get cosecant, secant, and cotangent?
Flip it.
Yes, flip it. So we also, if we know sine, we also know cosecant. We just have to flip it. We also know secant. We just have to flip it. We also know cotangent. We just have to flip it. So if you're always really organized about, and I always recommend finding these guys first, because again, this is really the A side of the album. These are the buttons that are actually on your calculator. These are always going to be sort of like, they're always going to be the priority. But we've also got the B sides, and sometimes, you know, we appreciate the deep cuts, and, you know, but if once we've got these three, we can just flip them all. And we've got, are you appreciating my music analogies, Miles?
Well, the B-sides are good.
The B-sides are good, but they're usually not the hit singles. These are our hits. These are the ones that chart, okay? I'm not saying they're bad. I'm just saying, though, once we've got Sokotoa, Choshikow, it's just a matter of flipping it. There's one other thing that I want us to review. We did it last week, and so we seem to remember, and we're just kind of taking it on faith so far here, that actually a 5, 12, 13 right triangle is possible. But if we want to confirm that we are correct, what is our formula that helps us to confirm that yes, indeed, this is a possible triangle? Yes, Gwen? That's right. So we can also, and I wish I had one more color, but I don't. And a squared plus b squared plus c squared used to be called the Pythagorean theorem, but what do we call it now? The Sumerian theorem. Okay, so we've got a squared plus b squared equals c squared. We're now having a lot of letters flying around, and we've got a big A and a little a, and can be confusing. A and B are always going to be the legs. So we can always rewrite this as O squared plus A squared equals H squared. C is always the hypotenuse. A and B are always the legs. This helps us to stay organized so we don't accidentally start plugging the numbers in to the wrong place. And so what's the length of our opposite side here? 5, and adjacent. And our hypotenuse is 13. What's 5 squared?
25.
What's 12 squared?
144.
What's 13 squared?
169.
Okay. Does 25 plus 144 equal 169? Yes, so this guy checks out. Okay, so there's our Sumerian theorem, and sometimes we're going to need this guy. Maybe we're not given all three sides. We need to solve for one, but the Sumerian theorem is going to pop up a lot in our trigonometry. Okay, you guys are doing an absolutely awesome job with this review, so please, you know, give yourself a pat on the back or put a little star on your notes, or good job. Okay, so what we are going to spend the next part of class doing, so everybody did get a syllabus at orientation. If you don't have it anymore, it is on Classroom. It's both posted in the stream, and I have also attached it to the 4.3 assignment, which is due on Wednesday. And what we're going to spend some time doing, we've just reviewed the knowledge that we are going to need in order to begin working on assignment 4.3. So that's what we're going to spend some time doing, okay? Before we all embark on that, though, pausing, just looking at our 6 trigonometric functions, our right triangles, our Sumerian theorem. Does anybody have any questions before we start doing some more practice? In that case, please feel invited to begin. And I would definitely recommend, actually, There's one other really important thing that I want everyone to do. Hold on just a sec. I'm giving everybody 2 Post-it notes. And I want everybody to turn to page 377.
Sorry, what page do you want us to turn to?
377. Okay. Your first Post-it, I want you to put so that it's sticking out of your book like a bookmark on page 377. And once you've done that, I want you to go to the way back to page A92.
I only got one sticky.
And I want you to use your other sticky and have that sticking out like a bookmark on that page.
I only got one sticky note.
You only got one? I'm sorry, I meant to give everybody 2. Okay.
And what page is it?
It's
377.
page A92. Not 92, but A92. So at the way back. Okay. And why have I had you put Post-it notes on page 377 and A92? Yes, Quid?
377 is the like assignment, and the one at the end is the like answers.
So you can check
Yes.
your answers.
So you can check your answers, okay? In this class, there's several really important things about how you turn in your assignments that make us following each other's breadcrumbs really smooth and efficient. And you don't want me wasting your time, and I don't want you wasting my time. So these are the things, these are my expectations for your assignments that will make both of our lives easier. 1, and this is in the syllabus, but all of your assignments should have the appropriate header. Why? Because then I know whose work I'm looking at, but also when you go back and look at it again, you can tell what chapter it's from. So these are just the kind of organizational things that also, like, when it comes time to be like preparing for quizzes, tests, and exams, you can go back and look at your own work and actually find it again. So super important. So header, super important. I want everybody to be starting out doing the honors level assignments. So both standard level and honors level are provided in the syllabus. I want everybody starting out at honors level. Yes, Quinn.
So do both the problems for honors and standard?
Just honors. Yes. And they usually overlap, but they're not the same. So I want everybody starting out doing honors level. Now, if you're already super familiar with trigonometry because your prior classes, and you're looking at this assignment and you are bored, then you just need to let me know, because there are other ways that we can make this more advanced. There's other material that we can turn to that's like in a separate section of the book that's related. On the other hand, if you're working on the honors and you feel like you are drowning and you are spending more than half an hour on your assignments outside of class time, then you also need to talk to me, because we can adjust and we can go to standard level, and that is helping to make the workload manageable while still moving through the material. And all of these options are all totally fine. So you need to have a header. I want everyone to start with honors. Okay, let's say that you're starting out on problem 1. Okay, and here's your scratch work, and like here's your sketch, and here's your, here's this, and you've labeled on it, and this is helping you to think. Do not erase that. That's awesome. It's good for you to give yourself breadcrumbs to like go back and see the work that you've done, and it also helps me to see your thought process. But in the end, you want to make sure that you have a complete answer that you have like highlighted in a box or something, so that both you can compare your answer to the back of the book and I could look at your answer. I can see both the journey you've gone on and the final destination at which you arrived. It's really important. Yes, Quinn. I saw a hand up on the prior point. Yes.
I had a question about the honors thing.
Yes.
So just when it goes to like our credits and stuff, does it change like on our transcription if this is an honors class if we do standard?
Yes. So, yes. So honors is, I mean, again, a standard level class here, there really is not going to make a huge difference. But honors level is better for your GPA. But how important your GPA is depending on the colleges that you're applying to, I mean, your mileage may vary. So this is why if you are starting out here and this is feeling like you have to spend more than half an hour on the assignment, then I would say reach out to me, because maybe there are other things that we can do. Maybe we can put together a study group from the class. Maybe this is a case where, like, if we have a focus study together, like, we can have a little bit more conversation. Or it could just be, and again, this would probably be a conversation also with parents and MJ from a college counseling perspective, just because we don't want to make any snap decisions. But if we need to, the adjustments are available there, because ultimately we want your overall schedule to be sustainable and manageable. Okay? One thing to note is this book kind of has, just in its language, and it kind of has a little bit of an attitude. Like the textbook has a little bit of a superiority complex. So Larson and Hostetler like definitely stick their pinky out when they're drinking their tea. You know, I mean, it's got a little bit, the book just has a little bit of a supercilious attitude. Okay, so if as you're looking at the book, you're getting put off by the language a little bit, you will get used to it. But it's normal sometimes to just be like, oh my gosh, Larson, Hostetler, why do you guys have such an attitude? It's because we're using a college level textbook. Okay, so just a heads up on that. It's actually a really great comprehensive book, but sometimes it's a little bit opaque. It doesn't have the nice pretty colors, and they have a little bit of an attitude. Okay, so persevere. But the other thing that is really important that I'm going to say about your assignments is to check your odd numbered problems. And if your answer does not match the answer in the back of the book, I am expecting you to start out with the troubleshooting. In other words, sometimes the easiest thing to do is just start the problem over on a fresh piece of paper. 9 times out of 10, there was just a simple mistake that was made. And just looking at the problem anew will solve the problem. On the other hand, if you do it again, and you are still getting an answer that's different from the back of the book, enter both the answers into your calculator and see if their decimal approximations are actually the same. Because we saw that like 3 times the square root of 3 is actually like 6.9 something. And you're like, well, wait a minute, I did this and I got about 7. But the book says 3 times the square root of 3. Well, sometimes those answers are actually just about the same. Okay? So 1, try the problem again. 2, use your calculator to check to see if you have the same answer that's just in a different format. It just looks different. 3, feel free to check in with a neighbor. I'm getting a different answer. Like, how did you do this? It's okay to use each other as a resource. And then, of course, if you're working independently at home, you can just comment on the assignment and say, Ms. Ferris, on problem number 37, you know, I'm getting 25. The book says 37. Here's a picture of my work. You know, can you help me? And again, if you get to that point, usually 9 times out of 10, I can just make a simple suggestion in the comments that then is like helpful enough to like move forward with that problem and then keep going. What I don't want to happen is that you know that Well, first of all, does it make sense if you're like on problem 30, problem 37, does it make sense to move on to problem number 39? That's the exact same format. If 37 didn't go very well? No, it doesn't. So I would say if you have questions, ask them right away. Ask me, ask a classmate. Don't wait until the assignment is due and then just turn it in with just like a bunch of blanks and question marks or just the wrong answers that you know are wrong, okay? We can keep moving pretty quickly here if we're asking questions as soon as they come up. But we only know that the questions are coming up most of the time if we're checking our answers right away in the back, okay? So check your work as you go. Sometimes students are like, oh, it's cheating. I'm looking to see what the answer is. No, it's not cheating. You are proactively, potentially catching errors or misunderstandings of the material right away so that we can fix them right away. So really valuable tool. Okay, any questions about any of that or what I'm expecting to see on assignments? Okay, the other thing to know is that assignments are due at the start of class. They need to be posted as pictures on Google Classroom. Assignments lose 10% every 24 hours that they're late until they get to 50%, at which point they drop to 0 and we just move on. If your assignments are late, your name goes on the whiteboard in the front until they get turned into me. So it's really important that we are being proactive, not reactive when it comes to our when it comes to our pre-calculus work. Any questions about that? All right. So now we've still got a good 23 minutes of work time where you can be discussing the work with your neighbor, you can be asking questions of me. This is a great opportunity to be moving ahead on this assignment and making progress to getting it done early. Yes, Quinn?
Would we be able to allow to listen to music while we work?
Yeah, you can absolutely listen to music while you work. That is totally fine in this class during work time, right up until it becomes a distraction. So as long as we use it wisely, that's totally fine. Great question. Any other questions? All right, then carry on.